So we are now beginning chapter 9. And in chapter 9, we're going to take what we developed in 7 and 8 and generate a firm's supply curve for a firm in a perfectly competitive market. And once we have a supply curve for a single firm, then of course we can add them horizontally, and that gives us a market supply curve. Now, our strategy in this is to identify the profit maximizing quantity for a firm to produce at every price. And our assumption that firms are profit maximizers enables us to determine then that quantity that will maximize profits for every price, and that quantity may be zero. You know, maybe the maximum profit that firm can make is zero or even negative. But in any event, we will associate then the profit maximizing quantity with every price, and that will give us a relationship then between quantity and price on the supply side, or quantity supplied and price, and therefore the firm level supply curve, which is simply that relationship then between quantity and price. So let me share the screen here for a second. And I want to do this just a little differently than I have in the past. I want to use my whiteboard. I personally think that the PowerPoint that the McGraw-Hill people have provided isn't very good, but this is what we want to do in this chapter. Describe the relationship between the firm's marginal revenue and its price, and then use that marginal revenue to explain how firms should determine their profit maximizing sales quantities. And when we identify, once we've identified that profit maximizing sales quantity for a price taking firm, we can derive its supply function or supply curve. And then we'll explain why price taking firms usually respond to price changes more over the long run than they do over the short run. And then we want to finish up with a discussion of producer surplus, which is the counterpart to consumer surplus on the supply side. So that's what we're going to do. Now, you know, we are going to argue here that firms choose their sales quantities in our context in the perfectly competitive market. You know, a perfect competitor doesn't get to set its price. It has to take a price. It's a price taker. And so the price taking firm chooses its sales quantities to maximize profits. And we will do so. We'll demonstrate how the firm thinks about going about that optimization problem. And that is to say, the firm will equate its marginal revenue to its marginal cost, and that will determine the sales quantity. And as I said, we are going to be looking at a competitive firm. So there we go. Now, let me address. So here I am. I want to do this like I would do it, if I can get to the bottom of this, on a whiteboard in a classroom. So this is chapter 9. And we might think of this as a chapter focusing on profit maximization and firm supply. Now, let's think about this. A firm's objective is to maximize profit. To maximize, we call profit big pie. To maximize profit. And what is profit equal to? Profit is equal to the firm's revenues minus the firm's total cost of production. Now, what do we actually have here? Well, we've already developed the firm's cost function. So we know that one. And the firm's, revenues are going to be price times the quantity that the firm sells, less its cost, which is going to be a function of the quantity the firm produces. So what do we have here? We've got profit is equal to revenues minus cost, and those revenues are a function of the price and the quantity, less the cost, which is a function of quantity as well. So the firm here, we're going to focus on Q. The firm will be choosing Q, its quantity, in order to maximize this term profits. Now, let me think of, I want to introduce a couple of ideas here. What would be the change in profit when the firm was to change its quantity of output? Well, that would be the change that would be experienced in terms of revenue minus the change in cost. And if I were to put this in marginal terms, then I would think of, well, what is marginal profit going to be then, by the way we think about this? Marginal profit is going to be equal to the change in profit for some given change in the firm's level of output. So this is marginal profit, delta pi over delta Q for some small change in Q. And since I divided the left-hand side of this expression here by Q, by delta Q, I have to do the right-hand side. Well, what are these two terms on the right-hand side? We already have the one on this term here. So what I have here is I have delta R over delta Q is marginal revenue. That is to say, it's the change in revenue associated with a small change in Q. Now, the easiest way to think about this is what happens to my total revenue if I were to produce and sell one additional unit of output. And, depending on, what type of market you're in, it could be either positive or negative, but for a firm in a perfectly competitive market, marginal revenue is simply the market price. So a price-taking firm, and that's our argument, that in a competitive market, all agents, whether on the supply side or the demand side, are price takers. So a price-taking firm then can't affect the market price by virtue of its own decisions. So if it produces an additional unit, it can sell the additional unit at the prevailing market price. Therefore, the change in its total revenues will simply be P. So a price-taking firm can always sell an additional unit at price P, the prevailing market price, whatever exists. So really, for my price-taking firm then, that tells me that marginal profit is simply going to be market price less, and this term we recognize from chapter 8 is marginal cost. All right. Now, let me just go back and keep this in marginal revenue terms, because we want to establish our profit maximizing golden rule. So whenever my marginal profit is positive, that tells me that if I produce an additional unit, produce and sell an additional unit, that my profits will go up. And since I'm a profit maximizer, I will go ahead and produce that unit and capture that profit. That's my goal in life. So whenever this is positive, I'm going to want to increase, Q. And what that means is, if my marginal profit is positive, that means that marginal revenue must be greater than my marginal cost. The additional money, the additional revenue that I capture by producing an additional unit exceeds my cost of production of that additional unit. So my profit goes up. Conversely, if marginal profit was negative, that tells me that if I were to increase my output, my profits would actually fall, so I wouldn't want to do that. But if my marginal profit is negative, if I were to decrease Q by 1 unit, my profit would go up. So in that case, that would tell me I would want to decrease Q to increase my profits. And obviously, in this case, this would imply that marginal profit is negative, would imply that marginal revenue is less than marginal cost. So the additional revenue I generate from producing and selling an additional unit is not sufficient to cover my cost of production. In fact, I can reduce output and my costs would fall more than my revenue. So my profits would go up. So whenever marginal profit is positive, I increase Q. Whenever it's negative, I decrease Q. The only option that's left is the possibility that marginal profit is equal to 0. And so when marginal profit is equal to 0, I must be at a maximum. Right? So if marginal profit was positive, I would be increasing output. If marginal profit was negative, I would be decreasing output. Where I'm happy is where marginal profit is equal to 0. That tells me that I have managed to extract all the profit that's available. And so I would stop right here, but that implies then that I would choose a quantity where my marginal revenue is equal to marginal cost. All right, since I've got this is equal to marginal revenue minus marginal cost. And if that's 0, then that implies that marginal revenue is equal to marginal cost. So this is my golden rule for profit maximization. And it doesn't really depend in any way, shape, or form on the market type. So the golden rule for profit maximization is to choose Q such that marginal revenue is equal to marginal cost. And now for a perfectly competitive firm, this is true for a monopolist, for a competitive monopolist, and for a competitor. It's true for any market type. But in a perfectly competitive market, we said that marginal revenue is simply equal to P, and that would then therefore be equal to marginal cost. So for a perfect competitor, we have then a perfectly competitive firm. Our golden rule will be choose Q such that price is equal to marginal cost. Now, your authors in the textbook, make it clear right up front that your profit maximization might occur at Q equals 0. So the rule needs to be amended calculate profit at Q, where price is equal to marginal cost, and calculate profit at Q equals 0, and choose the value of Q where profit is greatest. So we have two possibilities here. We have a possibility that your level of output is positive, and that would be the case where your profits are greater than your profits at 0. Or we have the other option, the other alternative, where Q is equal to 0 because your profits are higher at Q equals 0 than they are at the positive output level. So, let's think about this. What, for a firm in a perfectly competitive market, what does the firm's demand curve look like? Well, here's our perfectly competitive market for widgets or whatever. And we have some market demand curve composed of a zillion households. And we have some market supply curve composed of lots and lots of small producers, none of whom can affect the market price. And so what we have here is we have an equilibrium price established in the market that is fixed and generates the demand curve for all of the individual firms. I should indicate this as market quantity. Maybe I should indicate the firm by a lowercase q, but for the firm, it's a price taker, and it has to take this price that's established in the competitive market. So for our firm, the firm can sell as much as it wants at that price because none of its behavior is significant enough relative to the market to affect the market price. So for our firm, the demand curve is perfectly horizontal at that market price. Now note, this is also the marginal revenue curve for the firm. So the firm's price and marginal revenue curve are the same. Anytime it sells an additional unit of output, it captures price P. And so let's suppose the firm were to choose to produce here Q prime. Well, what's the firm's total revenue going to look like? Its total revenue is going to be the area of this rectangle, which is simply price times quantity. So this is the firm's total revenue gotten by selling Q prime of output. Now, if I were to think about this in terms of the firm's, back to the firm, in terms of the firm's cost curve, here's Q, and here I have this in dollar terms here. So I have, some cost function. Firm might have fixed costs, and here's the firm's, total cost function. It's looks like that. So here's cost. Well, what's revenue going to look like? Revenue is going to look like P times Q, which is just a linear curve. So this is R, and the slope here is P. This is the market price. All right, and that's what the firm takes. Now, revenues minus costs, well, this is my revenue curve here. Okay, let me make a different color. Let me pick a color here. What's profit going to be? Profit is going to be why did that do that? Oh, bless America. Profit then is going to be, it's going to be negative actually here, because cost, this is, cost, this is C up here, this is R down here. So this vertical distance is profit. And as you can see, R minus C is negative. Right here, costs are equal to revenue, so profit is 0. And right here, costs are equal to revenue, so profit is 0 at this level of output. And once again, after we go past this level of output, costs exceed revenues. So what do I get? I get negative profit up to this point. And then over this interval here, revenues exceed costs. So profit's positive. And then it goes back down to being negative. Now, what is my firm's goal here is to maximize profit. So the firm is going to seek that level of output where the greatest difference between revenues and costs, positive difference, exists. And so let me call this Q star. Well, we argued that the slope of the cost curve is the marginal cost. And this maximum will arise then, according to our thinking, at the level of output where these two curves are as far apart as possible. And so you notice over this interval here of positive profits, because the slope of the total cost curve is less than the slope of the revenue curve, which is P, this would be marginal cost, that is increasing at a lower rate, but right when I get to this point, then the slope of the two curves are equal. So marginal cost here is equal to the slope of the revenue curve, which is P. And then after I go past that point, marginal cost is increasing, or the cost curve is getting steeper than the revenue curve. So this vertical distance is decreasing. So the slope here of this curve is marginal cost. The slope of this curve is price. And where these two curves diverge the most, with revenue greater than cost, is the point where their slopes are equal. So from this geographic demonstration, I say that Q star occurs where marginal cost is equal to price for our competitive firm. Now, let's think back here to what our cost curves look like for this firm. When we look at average and marginal costs, so what we're saying here is that for our firm, we have some average cost that looks like this. And we have a marginal cost then that intersects that average cost curve at its minimum point. And so when we introduce then the firm's price curve or demand curve, remember this is the firm's demand curve is horizontal, then the firm will choose this level of output will be maximal because it is at this level of output that marginal cost is equal to marginal revenue. Now, is the firm making positive profits? Well, let's look at this. Profit, we said, is equal to, in this particular case, revenues minus costs. So if I were to look at average profits, it would be R over Q, which would be average revenue, minus C over Q, which is average cost. But remember, revenues are equal to price times quantity. I divide that by quantity. What do I get? I get just price minus average cost. So that my average profit is equal to price minus average cost. And that tells me that the profit would be equal to, well, I have to multiply through by Q, which just gets me back to the difference between price and average cost. So that would be this distance right here. This is price. This is average cost at Q star. So that's my average profit, price minus average cost. And if I multiply that by Q, then I get total profits. So my total profits would be that rectangle there. The difference between price and average cost times Q. Now, the story is a little more complicated than that. Let's just think back for a second. Where, well, let me go back to my drawing here and just do one more thing. Let me change colors again. What are my total costs here? My total cost, well, my total cost will be average cost times Q. So this rectangle here will be total cost. And as I said before, this rectangle is price times Q. So this rectangle is total revenue. So revenue minus costs is equal to profit. So costs and profit equate to total revenue. So this firm will definitely be happy to produce because it can earn positive profits when it does so. Now, I could draw this a little differently. I could draw this so that my firm is same firm, same cost structure. Whether I use a big Q or little q, I guess it's a mess. Here's my average costs. Here's my marginal cost, again, intersects that average cost at its minimum point. And now let me suppose that market price is right here. So this is my market price. Now, my firm, using always the same golden rule, it doesn't really matter. Price now is equal to marginal cost at this level of output. We call this Q double prime. And as you can see here, average cost now is greater than price. So profit now, which is going to be price minus average cost times Q, is going to be negative because price is less than average cost. So the firm's profits now are negative. And those are the maximum profits the firm can earn by operating. The best it can do, if it chooses to produce, is to have negative profits. So the firm may indeed choose at this point that to shut down. So, and this is our argument before, if profits when Q equals 0 are greater than profits when Q is equal to, our Q double prime here, the firm chooses, Q equals 0, right? So the firm will shut down or produce 0. Now, recall that the firm has fixed costs. Let's just do a little review here. So the firm's total costs, we said, there are variable costs, right? Vary with Q, and are 0 if Q equals 0. There are sunk fixed costs, that are fixed, of course. That's why we call them fixed costs. They're fixed and unavoidable. So sunk fixed costs, if they're positive, are greater than zero, even if Q equals zero. So we can't get away from those. So if we choose to produce zero and we have sunk fixed costs, then our profits are going to be equal to the negative of our sunk fixed costs. Now we said we have avoidable fixed costs. I call that AV fixed costs, are fixed, but are zero if Q equals zero. So then we define avoidable costs. Are variable costs plus avoidable fixed costs. So we have some new terms here. We have average variable cost, which we said was variable cost over Q. We have average fixed cost, which is going to be sunk fixed costs plus avoidable fixed costs. Those will be our total fixed costs. We have average avoidable costs, call that AAC, average avoidable costs, which are avoidable fixed costs plus variable costs over Q. So we're now going to focus on this avoidable versus unavoidable or sunk fixed costs. Now, our argument here is that profits now are going to be equal to revenues minus, costs. But what are my costs? It's going to be now minus, it's going to be variable costs plus avoidable fixed costs plus sunk fixed costs. All right. And now my average profits, which are indicative of my total profits, are going to be, average revenue, which is price, minus average variable cost, minus average, I don't know how I'm going to do this, average avoidable fixed costs, minus average sunk fixed costs. Now let me group these two together. What do I have here? I have now, it's going to be equal to price minus average avoidable costs, where average avoidable costs are the sum of average variable cost and average avoidable fixed costs, minus average sunk fixed cost. So once again, now I'm going to have my profits are going to be equal to Q times this terms here. Q. So everything's going to depend on this expression in parentheses right there. Now, note that if Q equals 0, then revenue equals 0. Avoidable costs, average variable costs will be 0. Average avoidable fixed costs will be equal to 0, but average sunk fixed costs, if they exist, will be positive. So that profit, if Q equals 0, profit will be equal to the negative of average sunk fixed costs times Q, which is simply the negative of sunk fixed cost. So if the firm shuts down, it loses it. All right, so if Q equals 0, the firm, if it has positive sunk fixed costs, will lose the sunk fixed costs. Now, if the firm is operating, and suppose that, and let me put an and in here, P is greater than average avoidable costs, then profits here are going to be equal to P minus average avoidable costs minus average sunk fixed costs times Q. And let me put this into two parts here. P minus average avoidable costs times Q minus, this would just be sunk fixed costs. So that if price is greater than average avoidable costs, then profit, then P minus average avoidable costs is positive. So that means that this first term will be positive, and Q is positive, then P minus average avoidable cost times Q will be positive. This is what we're going to call producer surplus a little later. But note, so the firm, I can call this also profits on operation. We're ignoring the sunk costs, and we're looking at the revenue here. Let me distribute this. This is PQ minus avoidable costs. Avoidable costs. So this is revenue minus avoidable costs. So the firm is covering its avoidable costs, and it's able to, at the very least, offset some of those sunk fixed costs. Now, if this revenue minus avoidable costs is greater than the sunk fixed costs, the firm will have positive profits. If these revenues minus the avoidable costs are positive, but less than sunk fixed costs, the firm will have negative profits. But by virtue of operating, the firm is able to offset at least some of the sunk fixed costs so that its profits will be greater than sunk fixed costs if it were to shut down. So note, if Q equals 0, that implies that profits are equal to minus sunk fixed costs. If Q is positive, that implies now that profits are equal to, as we said, the revenues minus avoidable costs, which we're saying is positive, minus sunk fixed costs, and that will be greater than minus sunk fixed costs. All right, so as long as the firm is able to cover its avoidable costs, it will go ahead and operate. And that might mean that the firm is earning negative profits, but those profits will still be greater than their negative sunk fixed costs. If the firm's excess of revenue over its avoidable cost is at least as great as a sunk fixed cost, the firm will be covering its sunk fixed costs, and therefore its profit will be at least 0, perhaps greater than. So if I were to draw this out, let me draw this out and then I'll stop. So here's my firm's cost curves now in this scenario. I have average total cost. I have now average avoidable cost. remember, this is the sum of variable cost, total variable cost, plus avoidable sunk cost, avoidable fixed costs divided by Q. And then I have my average variable cost curve. So this distance here would be average sunk fixed costs. And this distance here would be average avoidable fixed cost. Together, this distance here, this total distance here, is average fixed costs. And I have a marginal cost curve, which is going to go through the bottom of each of these curves. So here's my marginal cost curve. So what I'm saying here, up here, is that as long as price is at least as great as average avoidable cost, the firm will choose a level of output associated with the point where marginal cost equals price. So if I were to consider this point right here, for example, always said, we would take that point right there. Okay, and at this point right here, we have positive profits. Price is greater than average total cost. At this point right here, we have negative profits. So at that point right there, where can I put this? Pi is negative. But price is greater than average avoidable cost. So the firm will still operate. It's able to cover its avoidable costs. And at a price, say at this point here, then profits are negative. Price is less than average avoidable cost. So the firm will choose Q equal to 0. And its profits will be the negative of its sunk fixed cost. So in both the red and the blue, the firm chooses to operate. Where the red is earning positive profits, the blue it's earning negative profits, but greater than negative sunk fixed costs. And anything below then the minimum point on the average avoidable cost curve then becomes shutdown area. So coming back and redrawing this one more time, all my curves here, I've got my average avoidable cost curve. I have my average variable cost curve. Here's my marginal cost curve. And the firm will operate only when price at least covers its average avoidable cost, or total revenues cover those costs. So it will be right at this price here where my rule is to produce where price is equal to marginal cost, but it has to be at least as great as average avoidable cost. And since marginal cost goes through the minimum point on the average avoidable cost curve, since marginal cost goes to that minimum point on the average avoidable cost curve, it will be at that minimum point on the average avoidable cost curve where the decision to operate or to shut down occurs. So this becomes my rule here. My firm will choose Q such that price is equal to marginal cost if price is at least as great as minimum average avoidable cost. And I should say the firm will choose Q positive such that price equals marginal cost if price is at least equal to minimum average avoidable cost. And it's going to choose Q equal to 0 if price is less than minimum average avoidable cost. So this is what I call my shutdown rule in this context of profit maximization. So I'm going to stop here, and what I want to do next time is I'm going to show the firm supply curve then. Will be the same as the firm's marginal cost curve for all P at least as great as minimum average avoidable cost. So in essence, this becomes the firm's supply curve up there, okay? And if price then falls below that minimum average avoidable cost, the firm will choose Q. So it has this discontinuous supply curve. Q is equal to 0 for all price less than or equal to, doesn't really matter at equal, the firm's indifferent between operating or not, at the point between the firm will produce 0 for all price less than or equal to minimum average avoidable cost, and the firm will operate for all price at least as great as minimum average avoidable cost. So we'll get back to this, finish this up, get the firm supply curve, and then we'll talk about the long run in the next lecture. All righty? See you then. Bye-bye.